Alright, today I want to talk about section 1.7 that's called whole number exponents. And we use this to solve a problem that might look like the following issue. Let's take Sheila for example. And her parents tell her that she currently has $3. And for every month that she saves it, they'll double the money that she has. So after 6 months, how much money could we calculate? And the real question is, if we didn't know that she had $3, how could we write a variable expression to show this? So how could we write Now, for this style of problem, we're going to need a new kind of notation that we haven't used before and that we typically don't use until 7th grade. So this is one of those kind of new things that we'll start talking about. And we call these exponents. And I want to talk about exponents today. So the thing with exponents is that they give us a shorthand to talk about something that's kind of interesting. So say, for example, that I wanted to multiply a number by itself a lot of times. For example, if I wanted to multiply 4 by itself 7 times, I could write it like this. I could write 4 times 4 times 4 times 4 times 4, 1, 2, 3, 4, 5, times 4 times 4. This is 4 times itself 7 times. This is a lot of writing. And as we've kind of talked about before, mathematicians are really lazy and they don't like to do writing if they can avoid it. So what we do is we say we have a shorthand way to write this, and we're going to write this using exponents. So I can write this is equal to 4 to the 7th power. And in this case, let's take a look real close at this example. 4 to the 7th power. This little 7 here is a superscript, and superscript means that we kind of write it above the number, and it's kind of smaller as well, and that's kind of what they look like. And we call this, in this case, this number has a name, and we call this the, let me make sure that I use the right term that we use in here. We call this the exponent. And then this number here, we call the base. Now, what's interesting about these exponents is that they get large very, very quickly. So in this case, we can see that if I were to type in 4 to the 7th power on my calculator, might not work on that one. I might need to find a more scientific one. Let me grab the one on my computer. I can type 4 to the 7th. And the number I get, I could write 4 to the 7th is equal to 16,384. And that does make sense to me in my head because I'm really multiplying 4 times 4 times 4 so many times that number grows what we would say exponential. And that's in fact where this term comes from, because every times 4 after this, it will grow incredibly more than it did in the past. And that's why exponents are so special. Now, we have a couple special cases of exponents in that we have special names for them. If I have 4 to the 2nd power, I typically don't say this is 4 to the 2nd power. Instead, I say this is 4, where's my pen? 4 squared. And the reason for that is if I did have a square over here, and this side was 4, and this side was 4. To get the area of this square, I would do 4 times 4, and 4 times 4 is equal to 4 to the 2nd power, or 4 squared. And you'll notice 4 squared is easier to say than to the second power. So of course a mathematician would say, well, let's choose the easier one because we're going to use that a lot. And this to the second power we use all the time in mathematics. It's very, very common. So it makes sense that we'd have a shorthand for it. The other one that we typically have a shorthand for is to the third power. So we don't say 4 to the third power. We typically say 4 cubed. The reason we say 4 cubed is similar to the reason we say 4 squared. If we think about it, instead of having a square, instead now if I have a cube, I could say 4, 4, and 4 for height, width, and depth. And in order to get the volume of this, recall that volume is height times width times depth. That means that I'm going to multiply 4 times 4 times 4, which is going to give me 4 to the third power, or 4 cubed. So whenever I see 4 to the second power, I can say 4 cubed, or sorry, 4 squared, and 4 to the third power, I can write 4 cubed. Those are the things that we're going to be talking about. Now, the examples for today are going to be pretty simple, actually, because what you're going to be doing is you're simply writing down what is the exponent, what is the base, and what is the expanded form. So let's take a look at a quick example, and I don't anticipate people having a lot of trouble for these. Example 1, I need to know the exponent, the base, and the expanded. Okay, so if I write 6 to the 5th power like that, my exponent is 5, my base is 6, and my expanded form means 6 times 6 times 6 times 6, 1, 2, 3, 4, 5. Now, notice I put those dots because those dots are easier. You can, of course, put the little X's, but I would encourage you to move over to using dots instead of your multiplication, simply because we don't want to confuse them with the X variable, which we'll start seeing more and more of. If we quickly return to that original problem with Sheila and saving her money, we could write this for the 6 months. So she has $3 initially. Over 6 months, it's doubles. So I could write for month 1, she has $3. For month 2, she has $3 that's doubled. For month 3, she has $3 that's doubled, that's then doubled again. For month 4, she has $3 that was doubled and then doubled, and now it doubles again because I can write doubled as times 2. See the pattern here. I could instead write this as 3 times 2, 3 times 2 squared, because now I have 2 times 2. Now I can write this as 3 times 2 to the third power, and then now the pattern that I'm seeing is very obvious. So here I can write 3 times 2 to the fourth power, and 3 times 2 to the 5th power. And then I can even find out exactly how much this would be. So for here, she would have $3 after the first month, $6, 3 times 2. 2 times 2 is 4, times 3 is 12. Also notice we can just double from here. $24, $48, and what is that? $96. So we'll notice that her money gets very large very quickly with this style. Hope that makes sense. If you have any questions, ask around, and good luck.